This is practical number 2, analysis of randomized block design, RBD. In this first example, we are having an experiment was conducted to study the effects of temperature on the life in hours of a component. 4 temperature levels and 5 ovens. Ovens are serving as blocks. So these are serving as blocks, and temperature levels, whatever we are having, those we consider as the treatments here, were used in the experiment. The order of temperatures was randomized for each oven. The following results were recorded. So this data is given to us. Ovens are considered as blocks, and temperature levels, those we are considering as the treatments here. Analyze data completely. Determine pairs of treatments which differ significantly using critical difference method. So for this we are having linear model in RBDs. Xij equal to mu plus alpha I plus beta j plus epsilon ij for I equal to 1 to t. T is the treatments here, and j equal to 1 to b based the number of blocks here. So in this case t equal to 4 treatments we are having, and 5 blocks, b equal to 5 we are having, where mu is the general mean effect, alpha I is the effect due to I treatment, beta j is the effect due to jth block, and epsilon ij is the random effect, where epsilon ij's are IID normal 0 sigma square. That is the assumption here. Here we are using notations TOSS for total sum of squares, TRSS for treatment sum of square, BSS for block sum of square, and ESS for error sum of squares. So we are having here two null hypothesis, because we are testing blocks also and treatments also. So H naught T we are writing as mu1 dot equal to mu2 dot equal to mu3 dot equal to mu4 dot equal to mu here, or alpha 1 equal to alpha 2 equal to alpha 3 equal to alpha 4 equal to 0, and its alternative hypothesis H1T, that is at least 2 of the mu i's, that is mu I dots, treatment means are not equal. At least 2 of them treatment means are not equal. H naught B, that is mu dot 1, mu dot 2, mu dot 3, mu dot 4 equal to mu dot 5 equal to mu, or we can write beta 1 equal to beta 5 equal to 0, and its alternative hypothesis H1B is at least 2 of mu dot j's, or block means are not equal. So these are the hypotheses that we are having. So for calculating, what we do here, we have written the data given in the tabular form, obtained the total row wise also and column wise also. So here row denotes here blocks, so whatever totals we are getting, those are the block totals here. So we have written it as T dot j, j blocks we are having. So we are getting this as the block totals, and these are the treatment totals here, column wise totals are, and this is 6302. This is the value total of all these observations, 5 into 4, that is 20 observations here. Means we have obtained here, corresponding means how to get this mean, this divided by 5 observations, similarly this by 5, and such a way we are having this as the means here, treatment means actually, that we require for testing the specific treatments means differ significantly. T dot j square means this sum we are having, its square we have obtained here, likewise all the squares we have obtained, and this is the total, this is the total of all these squares of the treatments here, treatment totals here. Similarly we have obtained the, this is the block total square, this is the treatment total square here, and this is total of the Ti dot square here. Then in the next we are having Cf is equal to G square upon N. It is same for all the designs. G square means grand total, that we are having 6302 square by 20 observations we are having. So this we are getting as correction factor, or we can call it as correction term also, CF. Treatment sum of squares, we obtain 1 upon b summation I from 1 to t ti dot square minus CF. Ti dot square means treatment total, its square, that we are having this, and its sum we have obtained this value we are having. So this divided by 5 blocks we are having minus CF means this value. So after doing this division and subtraction, we will get this as the treatment sum of square. Similarly, block sum of square is 1 by 4. 4 treatments, value of t is 4. So 1 by 4 into t dot j square, and that t dot j square, that sum we are having as this value. So that we have substituted here, divided by 4 minus CF. CF is this value. We'll get block sum of square is this value here. Then for obtaining total sum of square, we require sum of squares of observation, that is double summation xij square. So what we have done here, we have squared each and every observation. This 340, this is the single observation, its square we have obtained, and that we have written here. Similarly, for all those 20 observations, we have squared these values, taken total row wise here, and then after getting this, we have taken total of this column. So this gives us double summation xij square. This value we are having as the double summation xij square. Likewise, yes, in the previous design CRD, we have obtained this total sum of square. CF is equal to g square upon n, that we are having this value that we are having in the previous case also. So total sum of square can be obtained double summation xij square, that is this value minus CF, subtract the correction factor, and after subtracting we'll get this value as the total sum of square. Then after that we obtain error sum of square, that we obtain by subtraction here, total sum of square minus treatment sum of square minus block sum of square. So we get this, substituted all those values what we have obtained here. This is the treatment sum of square, block sum of square, that we have subtracted, and we got that this value as the error sum of square here. Then all this information we are putting in the table. General table I have taken firstly, and then we'll put the values in this table. Here in this case we are having sources of variations, treatment, block, error, and total we are having. Treatment, T treatment, so its degrees of freedom T minus 1, B block, so its degrees of freedom B minus 1 here. Total number of observations T times B we are having. So total degrees of freedom we are having T times B minus 1 here, and this we are having error degrees of freedom by subtraction, or we'll have that is T minus 1 B minus 1 here. Here we'll write in sum of squares column treatment sum of square, block sum of square, error sum of square, and total sum of square. Then we obtain mean sum of square due to treatments, that is treatment sum of square divided by its degrees of freedom. Similarly for block and error also we obtain mean sum of squares, and then we obtain F ratio here, variance ratio we call it. F we obtain mean sum of square due to treatments, means this value, divided by mean sum of square due to error, and whatever F we are getting, it follows F distribution with parameter T minus 1 comma T minus 1 into B minus 1. So for this we see the table value here, and F for block we obtain, that is MSSB divided by MSSC, mean sum of square due to error here, and it follows F distribution with B minus 1 and error degrees of freedom, that is T minus 1 B minus 1 here. So this is general table. We substitute these values what we have obtained previously. 4 treatments, so degrees of freedom related to treatment is 3. 5 blocks, so its degrees of freedom we are having as 4. Total 20 observations, so total degrees of freedom we are having 19 here, and this we get by subtraction. From 19 we have subtracted this 7, we get 12 error degrees of freedom, or 3 into 4, that way also we get that as 12 here. Then all those obtained sum of square we have substituted here, treatment sum of square, block sum of square, error sum of square, and total sum of square. Then mean sum of square can be obtained. This divided by this value, this by this by this. We are having this as mean sum of squares here. Then obtained F ratio, that is this mean sum of square due to treatment divided by mean sum of square due to error. This 34870.2 divided by this 13.325. So this value is this value we are having. Similarly, we obtain FB. We call this as F ratio for blocks. That is this mean sum of square due to blocks divided by mean sum of square due to error. So we are having this value here. Then we see the table value here, F at 3 and 12. Treatment degrees of freedom and error degrees of freedom. So that is 312. That value we are having 3.49. And for block we are having 4 degrees of freedom for block and 12 for error. So F412 we are having as 3.26 that value we are having. This is actually table value here. Then we compare this calculated value with table value and we take the decision whether to accept or reject the hypothesis. See here, this value is calculated value is larger than this value. Similarly, here also for block we are getting this is larger than this one. So both the hypothesis of treatment means differ significantly. Those do not differ significantly, they get rejected here. So we have written here this conclusion here. Since Ft greater than F312, we reject H0T at 5% level of significance, that its treatment means differ significantly here. Our null hypothesis is do not differ significantly, so gets rejected. So we write here treatment means they differ significantly here. Similarly for block also FB, F calculated value for block it is greater than F table for block some block degrees of freedom. We reject H0B at 5% level of significance, that is block means differ significantly here. Then the second part is find a pair of treatments which differ significantly using critical difference method. So critical difference method, CD between any two treatment means x bar, say x bar p dot and x bar q dot at level of significance alpha is given by corresponding pth and qth treatment is considered here. So x bar p dot and x bar q dot we are calling here. CD is equal, CD of x bar p dot minus x bar q dot is equal to the critical value of t at level of significance alpha for two-tailed into square root of 2 MSSE upon B, that is equal to t at here error degrees of freedom we consider alpha by 2 into square root of 2 MSSE upon B. So this we are having t at this error degrees of freedom, that is 12 degrees of freedom here at alpha by 2 means 0.05. We see this value we are having as 2.179 multiplied by 2 into 13.325. This is the mean sum of square due to error. This we are having this mean sum of square due to error that we are having and divided by number of blocks, that is 5 blocks here. So after simplifying this we are having this final value as 5.30061. So this is the CD we are having. We'll get CD for all the treatment combinations same because we are having replication of treatment. For each treatment we are getting the same replication here because number of blocks it is fixed here. So CD is same for all the treatment means only we have to obtain the differences over there. Decision rule is if x bar p dot minus x bar q dot mod of this difference is greater than CD, x bar p dot minus x bar q dot means this value p not equal to q I from 1 to t, then pth and qth treatment means differ significantly, otherwise not. So we'll check for all the treatment combinations. So here 4 treatments, so we are getting 4C2 means 6 combinations we are getting 1 2 1 3 1 4 2 3 2 4 3 4. These many combinations we are having and their differences, corresponding differences means x bar 1 dot minus x bar 2 dot. This we have obtained. This we have obtained from this first table where we are having this treatment means we have obtained. Just see, this is the x bar 1 dot and x bar 2 dot here, these values taken subtraction here and taken modulus of that, means absolute value of that. If difference comes negative, we consider it as positive and then we take the decision accordingly. Same, all this difference is obtained same way, 1 3 1 4 2 3 2 4 2 5 3 4, and this CD is common for all the treatment combinations. We compare this differences what we are having x bar p dot minus x bar q dot with this CD. All of them, they are greater than this CD here. No one is less than this. So all the combinations we are getting its conclusion we are getting significant. So whatever treatment means we are having, they are differing significantly. So we write from this conclusion, since the difference x bar p dot minus x bar q dot for all the treatment combinations differ significantly, therefore we conclude that here all temperature levels what we have considered, that is treatments we have considered as treatments differ significantly. Okay, this is the second example. You have to work out this in similar manner. Only here blocks, 5 blocks we are having and 6 treatments you are having here. In the third example we are having calculate and interpret the efficiency of RBD relative to respective CRD for the following data related to RBD with 4 treatments and 5 blocks under comparison. So what we have given here, T equal to 4 and B equal to 5 blocks we have given, and sum of squares due to treatments, blocks and total, this is given to us. We have to compare the efficiency of RBD relative to CRD. So to find out this efficiency of RBD relative to respective CRD, that is given by E equal to capital E, we call it as efficiency, that is equal to B into T minus 1 capital SE square plus B minus 1 SB square divided by BT, B into T minus 1 SE square, where SE square and SB square, those are the mean sum of square due to error and due to block here. So we are having these 3 sum of squares we have given here, treatment, block and error. Its degrees of freedom we get here, 4 treatments we have given here and 5 blocks we have given. So its degrees of freedom we are getting 3, 4 and error, its degrees of freedom 12 here. Sum of square what we have given, that I have tabulated here. And how we get this error sum of square? By difference here. Total error sum of square can be obtained by total sum of square minus treatment minus block sum of squares, and that is 35.4. This we have written here, and from this we have obtained mean sum of square due to treatment that we are not requiring. Still I have obtained sum of square due to block divided by degrees of freedom here, that is mean sum of square due to block. Similarly for error, sum of square due to error divided by its degrees of freedom, we are having this value here. Then substitute here in this formula. B is nothing but 5 number of blocks, T minus 1 that is 3 here, multiplied by S square 2.95 plus B minus 1 that is B equal to 5, so B minus 1 4 into its MSSE that is 12.975. So this we are having divided by 19, BT minus 1 that we are getting as 19 here. B into T, 5 into 4 20 minus 1 it is 19 into S square that is 2.95, and after simplifying we are getting this value as 1.7154. Then we write conclusion from this. Since E greater than 1, this efficiency we have obtained, it is greater than 1, can be interpreted as RBD is more efficient than CRD. Since we are getting greater than 1, we conclude this RBD is more efficient than CRD here, and it is the obvious thing here.